Good morning, guys. This is the lesson after the intro to slope fields. When should we use separation of variables to solve a differential equation? And this is your first model. I posted these problems, by the way, in the folders on Edmodo, so you can either print them or just simply do them on loose leaf. Differential equation, first of all, is simply an equation that contains a derivative, like we see here. If you think about the word differentiate that we learned earlier in the year, differentiate implies find the derivative. So it goes sort of without saying, a differential equation contains a derivative. We're also given what we call an initial condition. This is of the original function. There's no y prime symbol here, it's that of y. So we are given 1 point for which the original function intersects. Here we have our derivative. And we, again, are going to have to find the antiderivative so that we can actually solve this equation. But what we have here is we have a derivative that is not solely in terms of x. It's in terms of x and y. And this would be the moment where you would say, okay, I need a slightly different technique to find the antiderivative. And that technique is the phrase that we see up here in the aim, separation of variables. And that is going to be our step number 1, separate the variables, which basically means that all of the terms that have a y in it, we want to get on one side of the equation, typically the left side, and all of the terms that have an x in it, we want to get on the other side of the equation, typically the right side. And to separate variables, the first step, most of the time, is to cross multiply. So dy times 1 is dy. Xy squared times dx is simply just that. We haven't separated the variables just yet because you could see that there's a dy on the left side, but the y squared is over here on the other side. So we're going to divide out by y squared. And also in doing that, we're going to rewrite the left side as y to the negative second power. Okay, so we've completed step number 1. We have separated the variables. Step number 2 is to integrate both sides. So we're going to find the antiderivative of y to the negative second power in terms of y. And we're going to find the antiderivative of x in terms of x. Okay, so in both situations, we would just be applying the power rule. So we add 1 to the exponent. And then we also want to make sure we divide the pre-existing coefficient by that new exponent as well. And plus c, which I'm actually going to write as c with a subscript of 1. We find the antiderivative of the other side. That's going to be 1 over 2x squared plus c, and I'm going to indicate a subscript of 2. This is going to be the one and only time that we're actually going to see this c1 and this c2. So if you think about it, you know, all constants are like terms. So we could, although we don't know what this constant value is, we could subtract its value over here. And if you think of the bigger picture, whatever these two constants are, since they're like terms, would just combine together to make an altogether new constant. So with that frame of mind, it's accepted to write just 1 plus c, and it's put on the side of your x terms, which again typically is on the right hand side. So again, this is going to be really the only time that you see me do these two separate c values. All right, so now at this point we are ready for step number 3. It's a 5-step process, so we're almost halfway there. We're actually going to find the c value. And we're going to be able to do that in this situation because we were given an initial condition. So I'm going to just say that that's negative 1 y to the negative first. So I'm going to sub in a 2 wherever I see a y, and I'm going to substitute a negative 1 wherever I see an x. And this level question would most likely be non-calculator, so try not to use the calculator to solve for c. 2 to the negative first power would really be 1 over 2 to the first power, which would be 1/2, which is going to give us negative 1/2 on the left side. Negative 1 squared is 1, times 1/2 is 1/2. And then we would subtract this 1/2 over, and it looks like our c value would be negative 1. Now we're ready for step number 4, which is to isolate y. With the c value subbed in. So if you go back up here, this was our outcome from step number 2. And now we can replace the plus c with our known c value, which is minus negative 1. So I'm going to show you a couple of techniques that would allow us to solve for y fairly simply. The first thing I'm going to do on the left side is to just rewrite this as negative 1 over y. And on the right side over here, what I'm going to do is make a common denominator. And we can easily do that by simply multiplying by 2 over 2, to this 1. So if we were to write this as one fraction now, it would be x squared minus 2 all over 2. I'm going to multiply by negative 1 because I definitely want to get that negative out of here. And when I multiply by negative 1, I'm going to get 1 over y. Now, don't fall into the trap of multiplying negative 1 to both the numerator and denominator, because then technically you're multiplying by a factor of 1. If you're multiplying by negative 1, you're really multiplying by negative 1 over 1. So the denominator for us is not going to change, but we will multiply the numerator by negative 1. So that's going to be, how do you like this if I write it as 2 minus x squared? I like to see the subtraction in the middle. Makes it look better to me. Now, in a very similar way where you would like square both sides of the equation, or sometimes we multiply by 2 on both sides of the equation, or sometimes we minus 6 on both sides of the equation, we're going to reciprocal both sides of the equation, and that's going to quickly allow us to solve for y. So this is going to become y over 1, which is really just y, equals 2 over 2 minus x squared. It's a nice strategy. Saves a little bit of time. So I have to go on to the back of my page just for a moment. So I mentioned before that there's a 5-step process, and this 5th step is often forgotten by students, and it can sometimes lead you to wrong answers. What you're supposed to do at the very end is to check your initial condition. So right now we have that y was equal to, I believe it was 2 minus x squared over 2. Let's just double check that. Excuse me. It was equal to 2 over 2 minus x squared.
Mommy.
One moment, baby. One moment. Our initial condition was y. Yes, baby.
This Autumn.
Autumn is sleeping. Just give me one more second, okay? We're gonna substitute in the initial condition into our final answer and just make sure it works. I'm so sorry, guys.
It's okay.
I
Wait.
want
How
to
about
know.
some help? It's okay.
I want to know.
And we do see that 2 equals 2.
But you know about that.
So now we can firmly say that this is the solution to our differential equation.